All right, so what's going on with reactions and reflexes in your brain and your body? All right, for starters, reactions and reflexes. I said they're a little bit different. So let's start with a reflex. We didn't test them, but what's a reflex? Well, a reflex is something that doesn't actually involve your brain. So for example, if you've ever been to the doctor and they've done the knee reflex test on you, that's where you sort of hang your knee loosely and they kind of bang it about there, oh, and your knee jerks away. That wasn't real, that was just me. What's going on there? Well, that's called the knee reflex, because when you whack the nerve there, it sends a message to your spinal column, which then sends a message straight back to the muscles to contract, and it causes that little knee jerk. So your brain is actually not involved in that particular thing. It's a reflex. The blink reflex is another one. When something comes towards you really quickly, your eyes blink. It's a reflex reaction because it's really fast and it needs to happen without a lot of delay with messages being sent to the brain. Right, so reaction times, what's happening there? Well, you probably noticed there's quite a bit going on, because the moment you see the ruler start to drop, a message has to go from your eyes to the visual cortex part of your brain. Oh, there we go, the visual cortex part of the brain. And it goes from the visual cortex, then that has to go, oh, something's dropping, we need to move. So it sends a message to the motor cortex. Now, if I was catching with my right hand, that means it's the left-hand side of my brain. That's the motor cortex that is going to be telling my right-hand side to move. So the brain sends a message from there, down my right arm, to the muscles to say catch. And all of that takes time, and that's your reaction time. For the eyes to see it, the brain to send a message to the brain, and for the brain to send a message to the arm to catch. So reaction times vary a lot from person to person. The average for humans is about 250 milliseconds. Or on a ruler, that's about 30 centimeters. But that's just the average. There's a huge variation. At about age 24, thereabouts, that's when reaction times are at their quickest. And after that, they will gradually get slower and slower and slower. Now, if you want to convert your distances to times, you can do that fairly simply. Well, I say fairly simply. You simply take the distance in centimeters and you multiply it by 2. Then you divide by 1,000, and then you take the square root of that. And that'll be your reaction time in milliseconds. But don't worry, teachers, I've got a little table that you can quickly convert most of these distances from 0 to 60 in the PDF if you want to work out what your actual reaction times were. Now, if you tried it with distractions, you probably noticed your reaction time when being distracted was a lot worse. And that's part of the reason we don't let people use phones and drive cars at the same time. Your reactions when distracted are always going to be a lot worse. Another cool thing to try is do it with both hands. So test your right hand and your left hand and see if your dominant hand has faster reaction times than your non-dominant hand. Certainly for me, I'm right-handed and I've got quicker reaction times with my right hand. So another interesting experiment to try if you've got time.